Hello friends, myself is Anjana Pawar from HM College Karad. In last lecture, we studied the inverse derivative of inverse trigonometric function, which is sine inverse derivative, cos inverse derivative, tan inverse derivative, cot inverse derivative, sec inverse derivative and cosec inverse derivative. And as well as we study the formula of inverse trigonometric of composite functions. Now, in this lecture, we study some important formulae of inverse trigonometric function. So, let's start. My first formula is sine inverse of sine x. Sine inverse of sine x. This is the identity formula. So, sine inverse of sine x is equal to x. Similarly, cos inverse of cos x is equal to x. Third, tan inverse of tan x is equal to x. Whenever is same ratio या same trigonometric function, here sine inverse and here sine, so we can write only angle. Similarly, cos inverse and cos, we can write only angle. Now, fourth formula, cot inverse of cot x is equal to x. Fifth formula, tan sec inverse of sec x is equal to x. Cosec inverse of cosec x is equal to x. So this is the identity formula: sine of sine, cos inverse of cos, tan inverse of tan, cot inverse of cot. Only we can write angle. But suppose sine inverse of cos x, that time this cos we can write allied angle formula. Allied angle means whenever is your ratio या your angle is pi by 2 minus x या pi by 2 plus x. So this cos we can convert into sine term. How to write? Sine inverse as it is. This cos we can write sine pi by 2 in allied angle minus x means pi by 2 means your ratio change. Allied angle कौन से होते हैं? pi by 2 plus x, pi by 2 minus x, pi plus x, pi minus x, या 2 pi plus x या 2 pi minus x. Pi by 2 means your ratio will be changed and pi means your ratio will be same. So here sine pi by 2 minus, pi by 2 means your ratio change, sine goes to cos, cos goes to sine, tan goes to cot, cot goes to tan. So is goes to the which quadrant? Pi by 2 minus x is goes to the first quadrant. First quadrant sine is positive, so this sine convert into cos, so cos x. Now again we can use this formula, sine inverse of sine. Sine inverse of sine we can write only angle which is pi by 2 minus x. Similarly, next formula, cos inverse in term of sine x. So again this sine x we can convert into allied angle formula. This sine we can write in the cos term. So cos inverse of cos, angle will be right pi by 2 minus x. So we get here cos inverse of cos. Again we can write only angle here. So we get here angle is pi by 2 minus x. Similarly, we can write tan inverse of cot x. So this cot we can write convert into tan term. So that time we can use the angle is allied angle. So here tan inverse of tan pi by 2 minus x. Again we can use the identity formula which is tan inverse of tan x. We get x. So we get here pi by 2 minus x. Next, tan cot inverse of tan. So same way this we can write cot inverse of cot, allied angle which is pi by 2 minus x. We get here answer is pi by 2 minus x. Now 11, sec inverse of cos x. So again this we can write sec inverse of sec pi by 2 minus x. Again we use identity formula. So pi by 2 minus x. Next 12. Cosec inverse of sec x. So this sec we can write in cosec term. So cosec inverse of cosec minus x. Again we use identity formula. We get here pi by 2 minus x. Next. So 12 formulae. Now next, which is sine inverse of x. We can write in term of cos x. That time the angle will be reciprocal 1 by x. Means suppose your ratio is sine inverse of x, or your function is sine inverse of x, and I convert this ratio or this function in term of cos x. That time only change the angle in term of reciprocal. So your x होगा तो यहाँ पे cos x इनवर्स करते समय रेसिप्रोकल लेना है. सपोज नेक्स्ट cos x इनवर्स ऑफ x होगा तो हमें उसका साइन इनवर्स में कन्वर्ट करना है, तो हम लोग उसका एंगल रेसिप्रोकल लेंगे, मीन साइन इनवर्स ऑफ 1 by x. Similarly we can write next sec inverse या tan inverse of x. We can write cot inverse of 1 by x. 16 cot inverse of x. We can write tan inverse of 1 by x. 17 we get sec inverse. Sorry, यहाँ पे नहीं करेक्ट था. cos x इनवर्स 1 by x, यहाँ पे sin इनवर्स 1 by x, यहाँ पे cot इनवर्स 1 by x, एंड यहाँ पे tan इनवर्स 1 by x. Now next sec inverse x. We can write sec inverse of x. We can write wait cos inverse of 1 by x, and 18 cos inverse of x. We can write sec inverse of 1 by x. So this is a formula for trigonometric function, inverse function. One more formula. Now write down next, which is 19 sine inverse of x plus cos inverse of x will be pi by 2. This is the identity standard formula. Sine inverse of x and cos inverse of x is equal to pi by 2. 20 tan inverse of x plus cot inverse of x is equal to pi by 2. Similarly, 21 sec inverse of x plus cos x inverse of x is equal to pi by 2. So this is the identity formula. Sin inverse of x plus cos inverse of x, which is we already proved sin square of x plus cos square of x is equal to 1. So similarly, sin inverse of x and cos inverse of x is equal to pi by 2. Tan inverse of x, cot inverse of x is equal to pi by 2. Sec inverse of x, cos x inverse of x is equal to pi by 2. And last 22, tan inverse of x plus tan inverse of y. This we can write tan inverse of x, tan inverse of y. We can write tan inverse of x plus y divided by 1 minus x multiply y. Tan inverse of x plus tan inverse of y, we can write single tan inverse x plus y, because here plus sign, divided by compulsory denominator contain 1 माइनस, यहाँ पे प्लस साइन होगा तो यहाँ पे माइनस साइन होगा, x मल्टीप्लाई वाई. एंड 23 फॉर्मूला tan इनवर्स ऑफ x minus tan inverse of y. That time we can write tan inverse of x minus y, because here minus sign, divided by first term is what, यहाँ पे माइनस साइन है तो यहाँ पे प्लस x मल्टीप्लाई y. So this is a trigonometric inverse formula. Now we can start some example for using this formulae. So before we start the example, we can solve one theorem. So write down the first that theorem. What is my statement? What is my statement? So write down here. Using a derivative, using derivative, prove that sine inverse of x plus cos inverse of x is equal to pi by 2. Sine inverse of x plus cos inverse of x, we can write pi by 2. This is a standard function, it has standard formula. So we can prove that by using a derivative function. So let f of x is equal to sine inverse of x plus cos inverse of x. So we can write here LHS side, sine inverse of x plus cos inverse of x. We can prove that f of x is equal to pi by 2. So we prove that f of x is equal to pi by 2. So differentiate, this is equation 1. Differentiate, equation 1, differentiate with respect to x. So f dash of x, whenever is f of x, we can write in differentiate f dash of x is equal to, what is the derivative of sine inverse? 1 upon square root of 1 minus x square. So 1 upon square root of 1 minus x square. What is the derivative of cos inverse of x? Which is same, only minus sign. So what is the cos inverse derivative? Cos inverse x derivative minus 1 upon square root of 1 minus x square. So this plus, we can write minus 1 upon square root of 1 minus x square. So these two terms are same. So therefore f dash of x is equal to 0. Whenever its function derivative is 0, that means function f of x function is a constant function. Because whenever is constant term f of x, suppose f of x is equal to 2. So what is the derivative of f of x? F dash of x is equal to 0. So we clearly here, if f dash of x is equal to 0, f dash of x is equal to 0, this implies f of x is constant function. Which function? Constant function. Let we consider here f of x is equal to c. c is any constant. 1 भी हो सकता है, 2 भी हो सकता है, कौन सा भी फंक्शन टर्म वहाँ पे हो सकता है. सो एफ ऑफ एक्स इज इक्वल टू सी फॉर एनी वैल्यू ऑफ एक्स. फॉर एनी वैल्यू ऑफ एक्स. एनी वैल्यू ऑफ एक्स. सो वी consider f of x must be c. So f of x must be c. Means your function क्या होगा f of x का? Must be c only. So put c only. So put x is equal to 0. Put x is equal to 0 in equation 1. In equation 1 we get f of 0 is equal to sine inverse of 0 plus cos inverse of 0. So sine की वैल्यू कौन से एंगल में 0 होती है? Which is 0. एंड cos की वैल्यू कौन से एंगल में 0 आती है? Which is pi by 2. चेक करो, sin 0 0, cos 0 pi by 2 is 0. So यहाँ पे क्या होगा? sin inverse of 0 0, cos inverse of 0 which is pi by 2. So f of 0, यहाँ पे x is equal to 0 पुट किया तो f of 0 so is equal to c is equal to pi by 2. That means f of x is equal to pi by 2 because for any value of x and x क्या लिया हमने 0. So f of c क्या मिला हमें pi by 2 means f of x is equal to pi by 2. Hence prove sin inverse of x plus cos inverse of x is equal to pi by 2. Hence prove. So again we can simplify. What is my theorem? Sin inverse of x is plus cos inverse of x is equal to pi by 2. So let f of x is equal to sin inverse of x plus cos inverse of x. We prove that here f of x is equal to pi by 2. So differentiate equation 1. Equation 1 differentiate with respect to x. So f dash of x is equal to derivative of sin inverse 1 upon square root of 1 minus x square minus derivative of cos inverse minus 1 upon square root of 1 minus x square. So f dash of x is equal to 0. Whenever its function is 0, that means function is constant function. So f dash of x is equal to 0, that means f of x is a constant function. So let's see, f of x we can consider here c for any value of x. So f of x must be c only. So put x is equal to 0 in equation 1. So we get f of 0 is pi by 2. That means c is equal to pi by 2. That means f of x is equal to pi by 2. Hence prove sin inverse of x plus cos inverse of x is equal to pi by 2. Now we can solve some example for this trigonometric inverse function formulae. So write down my examples. First example, differentiate with respect to differentiate the following function with respect to x. So my first function y is equal to tan inverse of log of x. Okay, tan inverse of log of x. Whenever is function coming, we can check the given function in standard function or composite function. So we know that tan inverse of x derivative. What is the tan inverse of x derivative? 1 upon 1 plus x square. But here tan inverse of log of x means x replaced by log x term. So here composite function. Standard function is tan inverse and sub function is log x. So first we differentiate with respect to x. That time we find the derivative of tan inverse. And again I differentiate with respect to sub function which is log x. So differentiate with respect to x. So this y we can write dy by dx. Tan inverse standard function के हिसाब से 1 upon 1 plus x square. X is replaced by log x. So here log of x whole square and again a derivative of log of x with respect to x. So what is the derivative of log of x, which is 1 upon x? So we get dy by dx is equal to 1 by x multiply 1 upon 1 plus log x whole square. Okay. Similarly, we can solve next. Y is equal to cos x inverse inside the bracket e raised to x. So cos x inverse e raised to x. Again this is a composite function. So first we find the derivative of cos x inverse and then we find the derivative of e raised to x. So straightforward, differentiate with respect to x. So dy by dx is equal to minus 1 upon square root of minus 1 upon square root of x multiply means minus 1 upon x. x क्या है यहाँ पे e raised to x multiply square root of e raised to x square minus 1. Because your cos x inverse x formula minus 1 upon x square root of x square minus 1. So here x replaced by e raised to x. So x replaced by e raised to x and again a derivative of e raised to x with respect to x. So we get a final answer. Dy by dx is equal to minus e raised to x divided by e raised to x square root of e raised to 2x minus 1 which is cancelled. So dy by dx which is cancel, minus 1 upon square root of e raised to 2x minus 1. Similarly, we can solve next example. Third example, y is equal to sine square inside the bracket sine inverse of x square. Correct? Sine inverse of x square. So again, this is a composite form. First, sine of sine inverse of x square, here sine square. So this is we can write in standard form. So y is equal to sine of sine inverse of x square whole square. Okay, but before you find the derivative, first we check here sine inverse या sine of sine inverse of x. We have an identity formula. Sine inverse of sine x या sine multiply sine inverse. Whatever term, we can write only angle. So here we can write only angle. So we get here simplify x square of square. Sine of sine inverse, we get only angle x square. Yes, sine inverse of sine, we can write only angle. Now this is simplified. So y is equal to x raised to 4. Now we differentiate with respect to x. This is the standard form, x raised to n. So derivative dy by dx is equal to 4x cube. 4x cube. I hope you understand. Again we can repeat. Sine square of sine inverse of x square. This we can write sine of sine inverse of x square bracket square. That means here identity formula used, which is x square of square, which is x raised to 4. Differentiate with respect to x. So straightforward formula, x raised to n, 4x raised to 3. Now next, y is equal to fourth formula, fourth example, y is equal to cot inverse of 1 upon x square. Now here cot inverse of 1 upon x square, here angle is reciprocal term. So we convert this cot in term of tan. That time y is equal to this cot convert into tan term, the angle reciprocal of reciprocal, which is x square. So now differentiate. It is a very easy to differentiate with respect to x. So dy by dx is equal to straightforward formula. This is a composite form. So first we use a tan inverse of x derivative, which is 1 plus x square of square, and again a derivative of x square with respect to x. So we get here dy by dx is equal to 2x divided by 1 plus x raised to 4. This is my final answer. So I hope you understand. Now next lecture we solve more example for same formulas. So thank you.